This video we are going to prepare a 3-phase controlled rectifier. So let's start with the blank canvas. First of all, we're supposed to bring a AC voltage source, and for that we'll go to library, and in library sim caps, in that power system, in that specialized technology, and in that we have varieties of sections, and in these varieties of sections we'll go to electrical sources. Here it is. So in electrical sources we'll bring controlled voltage source, we'll take a 3-phase source. You can directly take a single phase source and make it to 3-phase source, but here in this video I am taking a 3-phase source. And then we'll go to elements and we'll take series RLC branch. Once we get that, then we'll move towards the power electronics device that we want to use for this, and that is thyristor. We'll use thyristor. Once we have that, then we'll go to measurement block, and from here we'll use one multimeter, and then we'll have a 3-phase measurement block, and finally we'll go for scope. So we'll add scope. So I think majority of the things we have got here. Now we just need to arrange it in appropriate manner. So now I am going to prepare the circuit, so you just observe it. Okay, so our circuit is almost ready, and now we are going to add a power GUI block. This block is really very important for simulation, and you always need to use this power GUI block. If you want to know that what exactly the requirement of this power GUI block, then you can refer my another video. Now we are going to generate pulses for all the 6 switches, and for that we are going to use pulse generator. So let's get it. So this is our pulse generator. Now in order to generate the pulses for all these 6 switches, what is the exact sequence in which you are required to generate the pulse? So for example, if we are taking pulse at 0 degree, then switch 1 we will fire at 0 degree, switch 6 after 60 degree, switch 3 after 60 degree, switch 2 after 60 degree, switch 5 after 60 degree, and switch 4 after 60 degree. So there are total 360 degree in one cycle, and we have 6 switches. So 360 divided by 6 switches, so we'll get a gap of 60 degree. So after every 60 degree we'll fire the switch, but the switching sequence would be like this: T1, T6, T3, T2, T5 and T4. So now let me arrange the pulse generator for all the 6 switches. First we'll start with this. Amplitude 1, time period would be 0.02 second. Pulse width is 5%, this much is enough. If you want to go for 10%, that much is also enough. And now here I am going to write the equation to convert the phase delay seconds into the degree, right? So A into 0.02 divided by 360. So this is the equation. So after S1 we are supposed to go for switch number 6. So we'll name it as S6. Let's connect it. But what is the sequence? We supposed to turn it on after 60 degrees. So this is A is our firing angle. So what we'll do, we'll add 60 degree to it, right? After switch 6 we should go for switch 3, that is after 60 degree. So after 60 degrees 120, then we should go for switch S2. So that is after 60 degree so that is 180 degree. And here you will get one verification check, that is the switch S1 we are starting at 0 degree, right, it is at 0 degree, and switch S2 we are starting at 180 degree, right. So switch S2 we are turning on at 180 degree. So it should be a gap of 180 degree in single lag, because if we turn on switch 2 device before 180 degree, what will happen, there is a possibility to get a short circuit in between this lag. So at least a gap of 180 degree should be maintained between the two switches of same lag. Now after S2 we'll go for S5, right, and we'll add another 60 degree to it. So after 180 it should be 240, and after S5 we should go for S4. So for S4 we'll add the gap of another 60 degree, so it will become 300 degree, right. So I think gate pulse of all the switches is ready, and now we are supposed to go for measurement of voltage and current. So here we'll take a branch voltage, right, we want to measure branch voltage. Okay, this shows the error. The error is nothing but we have not provided the gate pulse here, right, because A is still unknown, and that is why that error is shown. So let us define A here. Let us say A is equal to 0 degree, right. Now we have defined A. Now there is no issue here. R load, will take it and close. So we are measuring R load, and now we'll start measuring a 3-phase voltage, right. You can directly bring and add another signal to the scope. You are not supposed to go and add another signal into the scope. So now we'll open the scope, and if we want to change the view pattern, then we can set the layout is like this, right. So in top we'll get 3-phase supply voltage, and in another section we'll get the output voltage. Now we'll adjust the time. I think for 0.1 second time it's enough. We'll save this file. So 3-phase control rectifier is the name of our file. Now let's run. Oh my god, the output is very weird. This is because we have not set any parameter for the source. We have did all the calculation for 50 Hertz, right. Gate pulse sequence we have arranged for 50 Hertz, and here it is 60 Hertz. So that is the problem. And now let's say phase to phase voltage, we will keep it as 415, and we do not want any internal impedance. Let's go again, and there we go, that's right. So these are the 3-phase voltages, and this is our output, a DC output. Now you can even measure the supply current as well as the load current using this branch current, branch voltage and branch current.